This slidecast presents a class hierarchy for shapes, and it illustrates an abstract class and pure virtual functions. The problem we're trying to solve is that we want to process some standard geometric shapes. Each figure object is going to be one of three standard shapes, a rectangle, a circle, or a right triangle. And we want to do some standard computations, such as finding the area or finding the perimeter. For every geometric shape, we need a class to represent the shape and know how to perform the standard computations on it. These classes will be rectangle, circle, and right triangle respectively. And to ensure that these classes all define the required computational methods, they all need to implement an abstract class called shape. And if the class doesn't have the required functions, then we'll get a syntax error when we attempt to use it. Here's a UML diagram that shows a base class shape that has four methods. They'll be pure virtual methods so that we cannot instantiate a shape class in our programs, but these three derived classes will all inherit from shape, and they'll all be required to implement those four methods. They'll each have their own unique data members, and they'll each have their own unique implementation of how to compute these functions. For instance, here's the rectangle class. It has a height and a width, and it will implement these four functions. Here's the header file for our shape class. It's an abstract class because all of the methods are declared virtual. And it says equals 0 here. So there's no corresponding CPP file and no implementation for these methods. The intent is that derived classes will implement these methods. Here's the header file for a derived class rectangle. It inherits or extends shape, and it'll provide an implementation of these four methods. Notice, since there's no virtual keyword here before these functions, this is not an abstract class, and all these four methods are required to be implemented. And here's the CPP file for our rectangle class, and it includes the implementation for these four methods. These were these pure virtual methods inherited from shape. And finally, here is a testing program. So here's a program in the main routine. The interesting things to note are there's a variable myShape that's a pointer to a shape object. Remember, we can't create instances of class shape, but we can have pointers to objects that are derived from shape. So notice myShape, we assign it the result of a call to this getShape function. And here's getShape, and this function prompts the user to select what kind of a shape the user wants to work with, and then it will create either a circle, a right triangle, or a rectangle, and it will return the pointer to this new instance back to main. So a pointer to a shape object will be assigned to myShape. And then myShape will invoke some of these four methods that are defined and implemented across any shape object. So notice that main doesn't know, the person who coded up main didn't know the type of instance that would be pointed to by myShape. So this getShape function is an example of a factory function because it creates a new object and returns a pointer to it. Now you will need to have factory functions in some of the labs that you do this semester. So go back and study this getShape function and have a clear understanding of what it means to be a factory function. Okay, you return a pointer to a class that you create in that function. So we have to create these objects using the new operator because we have to dynamically create this instance at runtime and return a pointer to it. We can't return a pointer to a local variable in a function because that variable goes away, goes out of scope when the function returns. So a factory will create instances using the new operator. As I mentioned, the main function has no awareness of the individual kinds of shapes. And the knowledge of the available shapes is confined to the getShape function. And it presents a list of the available shapes to the user, it decodes the user's response, and then returns an instance of the desired shape. This is the end of this slidecast.